All right, let's get things kicked off. I am Rex Reed. I am a business segment director for BSS Audio and DBX Professional Products for Harman Professional. And today I am very happy to introduce our next speaker. I worked with him closely on introducing AVB when we introduced it on the SC32 and 64. And I learned that he is one that is really willing to take chances, more than I expected. He's a great guy, great person to work with. From Onstage Audio, Jim Risgin.
Damn it, I wanted a music pad. This is all the graphics you're going to get out of me. I think they put me in this time slot to be the comic relief after lunch. As Rex said, I'm probably the earliest adopter of the technology, and it's been interesting and challenging to execute. But the reality is, and the first message I have to say is that once we got past the hurdles of the unknown, it was really a simple product to execute, simple protocol to execute. The transport worked well. It just worked when we started. You know, I can relate the stories of what the systems were and what the configurations were, but you know, it's simple endpoints, talkers and listeners. It was all done with SC32s and in the initial phase, done with some Crown amplifiers with some specially modified USB 4s with AVB on them. I found it to be not that much of a challenge. I actually was probably more at ease with it and using it than the Harman support team that came out to help me. Amazing, isn't it? So when I first deployed the first system, it was with a handful, I think 4 SC32s, 4 Netgear switches, and 24 amplifiers, which Crown may get mad at me for saying this, kind of went down to 18 after some died, but that's why there's not a pip guard anymore. But still, it was a significant number of nodes for a first implementation. Going through the design process, I was given a figure of 40 streams, talking streams, and be able to listen past that. So I started mapping out the design and working at it, and came up with a reasonable design that used something like 38 various streams and paths. So we get the gear into my warehouse and get it all plumbed up and talking to each other, and realize that, well, maybe we'll start with 28 streams. And finally whittle our way down to 13 being the magic number that we used for the first implementation. But once everything was up and running, and once we came up with that number and the system, the design, it was a fairly painless process. Power cycling is no problem, nothing lost, nothing dropped. Talkers listeners would identify the streams and come right online. So in a nutshell, with a drop and drag interface, it was a very simple system to execute. With not a single hitch for the shows that we used it on. I then took it out on shows with no support from Harman, and same thing, same results. Same system, so there was no configuration nightmares. That just worked. It was a matter of just, you know, coming up with a new design and configuration. With that said, I think AVB is a phenomenal place to be, or a place to start. You know, I've been looking at this technology and wondering about when we would get to a standardized platform. And I'm glad to see that we're finally reaching that point, because it's a holy grail of mine to reduce the infrastructure cost. It's a holy grail of mine to make it easier for us to tech an entire system. The ability for one person to see how the entire health of the system on a portable basis is extraordinary. It reduces the amount of people I have to have on site. It reduces my worrisome issues of whether or not a system's even functioning. I can actually go and look at the health of the system from the get-go. That is all very easy with AVB. The routing is easy with AVB. The networking is simple. You know, unlike installation work, portable PA makes it a little more difficult when I'm the IT professional. And that's what is critical in this whole portable solution. We can create protocols all day long. We've all looked at the fun stuff, and we like to make fun of CobraNet, but I would never ask a new person to try and configure a Kubernetes system, even if it's a simple only 32 channel system, just because of the potential pitfalls in designing, you know, bundle counts and everything else. It's just too hard. This is an easy system. It just works. I've used it on shows for General Motors. I've used it on shows for Kawasaki. Red Bull was an interesting one we can go into in a minute, which is part of the bleeding edge. I've even used it with Harman as a client, where we were doing a CEO conference for them, and the entire general session room was driven on an AVB backbone. The unique thing about that was it was a system that was configured by an engineer that's never used it before, with no tech support from anybody at Harman, and it was just a matter of me giving him the gear and saying, make it work. A day later, I call him up, I said, any problems or questions? And he's like, no, it's been running for, you know, better part of the day already. So to me, that's the proof of what AVB brings to the ease of use and operation. You know, at that conference, we did add, to answer some people's questions, we did add video components. We added hot patching and had instant discovery of devices that reestablished streams. And, you know, I believe it was under 100 milliseconds for the streams to resolve themselves and to show up. It was certainly fast enough where none of us were sitting there going, God, I hope it works, I hope it works, I hope it works. It just worked. The AVB side has taken the network out of the, you know, taken the configuration of audio over the network out of the picture. It's just become that, you know, I keep using it, but it's just that easy. It's just that simple. The only hurdles that I've had have been what you would consider standard, you know, teething pains. The one hurdle was the biggest hurdle I had was on a Red Bull event. So we're doing a Red Bull Flutog, which was an event where, I think it's 32 teams of crazy people build airplanes out of cardboard and other devices, you know, materials that they can't hurt themselves with, get up on top of a 30-foot platform, run, and push it to see how far they can fly. Normally they make it about 8 feet past the edge and drop 32 feet into the water. This event was in Long Beach, which is a unique horn-shaped harbor. And we had audience that was at the launch at the runway going around both horns. From point to point, it was probably a 8,000-foot cable run. And I had the judges at one end, I had the majority of the audience at the other end, and I had, in the middle, I had the runway. So using standard configurations and standard solutions, I could have gone to, you know, your standard telecast and fiber solutions, but the client didn't have the money. The client's asking me to try and figure out ways to resolve his budget issues with technology. And this technology gave me the ability to do a simple fiber conversion and use fiber, single mode fiber, to get to the network switches, of which my Harman support staff was like, oh, we think it'll work. We haven't tried it yet. And the reality is it did work. I had one problem where the, correct me if I'm wrong, it was the network, the PTP clock, because of the additional latency of the fiber, would lose itself and lose its mind, and I had to reset it a couple, 3, 4, 5, 20 times during the show. But other than that, it worked and it was functional. My clients were very happy. They knew that we had problems, but they also knew that the problems were easily resolved, and they also knew that I delivered a product to them at a price point that was acceptable to them. And that's, you know, that's important. The other important thing is that we've learned from our mistakes. All the, you know, that problem was resolved and hasn't come up since. You know, I keep getting asked about this because I believe I'm the first adopter, the first user in the field. Crazy person that I am. But I feel strongly that it's an important solution to a lot of things. I'm tired of going back to Lee's introduction with the single point source and the cable and a single cable for this and the troubleshooting problems that's plagued us for years. And as our infrastructures, both, you know, hard installed and portably, become more and more beat up, we have more and more problems resolving these issues. Do we spend more money to fix an old, outdated infrastructure, or do we move towards a newer thought process? Do we look for solutions that allow us to transport all our audio sources, intercom, audio, video, sends, receives, amplifiers, microphone inputs, splits, consoles on a single backbone, or do we continue to put in 4 to 5 to 6 backbones per event or per installation? That, to me, is a no-brainer. I want what's easier. I want what's cheaper. I want what's easier for me to tech. I want something that I can easily go through and troubleshoot. That's something that AVB offers me. I can go through with a single control system and look at all the devices and the health of the system on the node. I can look at the health of the AVB network on the node and the health of what we're doing to deliver it. And that is something that we can't do in any technology today. You know, forget the transport side, you know, let's look at the whole health of the system. Having everything interconnected, having, you know, the transport's almost secondary to some of the other issues of what, you know, system health is. Transport's easy. The rest of it is knowing what's working and how it's working and if you have potential failures. Knowing that you can go talk to your amplifiers that also are getting the audio on the same path and verify that your speakers are still working. I mean, that's all great things to me. I know that most of you do installation work and not portable, but portable really is a different beast and a more, what? I'm done. I'm done. Fine, thanks. Adam says I'm done, so therefore I'm done. In a nutshell, I really think it's an important way to go. I'm a firm supporter of it. And Rex, back to you.
All right, next, John is going to come up and introduce our next speaker.
Hi there, I'm John McMahon, and I'm the Executive Director of Digital Products at Meyer Sound. It's my great pleasure to introduce you to Mr. Vikram Kirby. Vikram is the Director of Technical Design for Thinkwell. They're a design and production company active in themed entertainment, museum and theatrical productions. While at Thinkwell, Vikram has managed and led design efforts for projects for clients including Cirque du Soleil, Disney, Franco Dragone, Resort World Sentosa, and Universal Studios Hollywood. In the past year, he and his team have opened or revamped 5 major projects, most recently the Harry Potter studio tour at Warner Brothers London, and the new nighttime spectacular and daytime parades for Universal Studios Orlando. Vikram holds a master's in fine arts and sound design from the California Institute of the Arts. Take it away, Vikram.
All right. Thanks. Yeah, just to give you some background, basically we deal most often with fairly large projects. So the sort of 5 projects we've played with over the past year, it was the Harry Potter studio tour in London, these 2 attractions for Universal Studios Orlando, the new Cirque show in Los Angeles, Iris, which is at the now Dolby Theater, and a revamp of a park-wide audio system at a theme park in the UAE. And so between those 5 projects, I did the math the other night, and it was 1,488 channels of audio. So a typical project for us weighs in at about 300 channels. Some of them are larger, some are smaller. You know, talking about this, I'm definitely sort of the guy in the rack room trying to make these systems go and looking at, you know, why is it that I think AVB is a good solution for a lot of the problems we face. And basically the first reason is clocking. It seems to me that now when we look at laying out a system, especially a large distributed system across many rack rooms, we're sort of given a choice, right? We can go to sort of AES standard things, you know, MADI, things like that, and essentially just assume all the signals get there at the same time and hope that there's enough buffering in the system that that assumption doesn't bite you. There's also always the option of just accepting non-deterministic latency and letting everything get sample rate converted. And then, the last case is sort of what we typically end up doing, which is taking the worst case latency as the system norm, and then you have to count on essentially just balanced network topologies to ensure that you get isochronous packet delivery, right? That's sort of a fancy way of describing a Kubernetes deployment. Priority 2, right, interfacing. And this is, to me a little bit, this is the elephant in the room. What good is an open source protocol if everyone's using it to connect brand X's stuff to more of brand X's stuff? And that's kind of what we've seen so far. And I was happy to see that last month, out at our office, I was able to get Meyer and Riedel to sit across the table and basically plug their stuff together, and we got audio to sort of flow between it. And that was the first time I'd ever seen multiple manufacturers' equipment, even members of the Avenue Alliance, talk to each other outside of the trade show environment, right? I've been coming to many trade shows and seeing this, but I sort of got to see it without much setup and without a lot of help in our office, and that was a big deal. One of the things that we deal with is we commission a lot of systems and deal with a lot of rack rooms and a lot of cable. And so we've sort of had to develop the same skills that I think everyone else in this room has worked with in terms of how you commission and deal with these very large, very complex IT-based deployments. And really, it's sort of what happened is I realized that it used to be we just took the oscilloscope, because most of the problems we were dealing with were power or termination. Now we end up taking the oscilloscope and a pile of computers and things like Wireshark along with us, because we're basically troubleshooting on both ends. And so I'm afraid that, for me, AVB is not this panacea that basically makes our job as the consultant irrelevant because it all just works. For me, it's more about the fact that it's a whole set of our problems of interfacing and managing bandwidth that we don't have to worry about. So we can worry about a lot of the simpler problems that we still face on commissioning. Are the loudspeakers pointed in the right direction? Are they turned on? Sort of the stuff that we actually got into the business to work on and worry about. One of the other things is just a word about VLANs. I'm very, very paranoid, and most of the successful people in this industry are as well, right? Every system you deploy, you are thinking about, how is this going to fail? What am I not thinking about? What did I write on this rack that's going to make the janitor think that this is where you plug in the vacuum? And so I'm holding on to my VLANs, and so I think that they are going to become optional as more and more devices sort of respect stream reservation. But for our large distributed deployments where you don't have someone in front of every rack and you have 20 of them scattered about, we're going to use VLANs as just one more tool to help harden our network against whatever anyone's going to throw at it. But the difference is that we're not going to have to manage the job we did in Orlando, which is really not that big. I think there's like 53 VLANs, and that right now that's just Kubernetes traffic management. That is still as fragile a system as you can come across, but it's because we need to not overwhelm CM1 cards with multicasting. And so that's the difference, right, is that the VLANs are going to become a prophylactic measure against not getting that phone call that Lee talked about. It's not going to be about actually getting, the test tone to come out of the speaker in the first place. A few notes about talking to your system with AVB or anybody else's protocol. In truth, we use a lot of USB Ethernet adapters, so we buy them by the handful. Part of the reason for that is that we end up segregating tasks, right? Because if you look at any of these deployments, you've got your loudspeaker amplifier monitoring, you've got the show control system, which you're probably interfacing to with TCP/IP or UDP or serial encapsulated over Ethernet. You've also got your just audio transport. So that right there, I mean, that's kind of the minimum, and you've only talked to the show control system. That's 3 somewhat segregated networks, and we often find that, you know, I'll admit, like, I'm a Mac user, and most of these things are done on PC, and it's actually been great because we just dedicate virtual machine instances to each task. So you've got the virtual machine you open up when you want to deal with your loudspeakers and your amps, and you've got another one you open up when you want to deal with Medialon or Crestron or whatever it's going to be. So yeah, know how to use Wireshark, because when you're troubleshooting, it's very helpful to be able to look at it and figure out that, you know, we deal with lighting guys a lot. There's a protocol called ArtNet. ArtNet's kind of like spam on your network, and it's really easy to see it on Wireshark. Just a few little points here. We try to only use one zero-conf network per system. Right, the appeal of IPv6 devices and Bonjour is that you can kind of get away from deterministically assigning all of your IPv4 addresses. The issue we run into is that if more than one group on a project has that clever idea, you can never connect to both of them at the same time, because, you know, your computer doesn't know which device that doesn't have a valid IPv4 address or a routing for it is supposed to be the one you're using. We also like to keep segregated networks separated by at least a Class A subnet. You know, use the 10.1 range for something and the 192.168 range for something else. We've had too many jobs where we thought we were being very clever and had 192.168.1 is all our DSP boxes and 192.168.2 is all of our playback. Only to discover that on default boot up, the DSPs go to 192.168.7. You know, it's things like that. Another point, and this is something that even this we question, this is how paranoid we are, but DHCP servers for your IPv4 devices, it's actually great. We tend to write out these lists with 300 IP addresses for everything, and then you're trying to remember when you go back to that job, if I'm 1.241 in this virtual machine and 1.240 in this one, there's a lot of places where DHCP can help that. Just a word about network links, right? At the end, we're all talking about managing bandwidth. I think it's very important because we see this a lot when we look at designs. Understand if your use case is symmetric or asymmetric and design it accordingly, right? You might need a 10 gig link between all of your playback and all of your processing. You probably don't need a 10 gig link between your processing and a delay tower or a vault with 4 speakers on it. And there tends to be this runaway arms race in terms of, oh, we're doing an all 10G network or an all 1 gig, and it's wasted dollars. To that point, link aggregation, you can use it as a fatter pipe. On Iris with Circ, we have, that's a weird show in that it's basically an install that's in touring racks, everything's in multi-cable, and it loads out for the Oscars. So it's sort of this strange hybrid we had to deal with, and because of that, we couldn't co-locate a lot of equipment. So we do have some link aggregation going on where we needed, we didn't need to get to 10 gig, but we needed basically 2 gigabit connections between some of our I/O modules and our processing. And so in that case, you know, between that point, the link aggregation is a fatter pipe. We have other runs between a front of house control position and processing where we use the link aggregation as a backup scheme, right? We've aggregated a fiber port and then a copper port together, and we don't need the full bandwidth of either. So that way you can basically drive the forklift over one cable or the other, and they do cross the stage on opposite sides. Getting back to dealing with VLANs and separating it, you know, configure a spare untagged port for every VLAN on every switch. There's nothing more frustrating than not being able to get to some portion of your system from the rack room you're in because everything is segregated too well. Another point is use the same VLAN to physical port mapping on all the switches throughout the system. This way you can tell the lighting guy to take port 7 in every single rack room you're in, and he doesn't have to look it up every time. And sort of to that point, you can troubleshoot very quickly. You know, we use Red Cat 5 cables for primary audio, and it's on port 2 in every rack room in the deployment. Back to specifically with AVB, different manufacturers do it differently. Look at the default channel count per stream of your connected devices. And this math's a little bit different, but it's at 9624. But essentially, the overhead of sort of the traffic management and the packet header means that, you know, 1 channel per stream, you get 93 channels, and at 24 channels per stream, you get 216. So you do have to think about that. Basically, my last thing is, you know, what is the promise of AVB? Why do the consultants care? And for us, it's the interoperability without a per-port license fee. You know, no, there are a lot of proprietary protocols that, especially to the end user, are indistinguishable from AVB, right? The audio gets there, it all works. But no one manufacturer makes every product. You know, we deal with intercom, we deal with media servers, we deal with loudspeakers, we deal with a lot of DSP processing. We need multiple manufacturers to be able to interface, and we don't want to spend our clients' dollars on the licensing fee to do that. We'd rather spend it on the quality of the equipment. You know, CobraNet has allowed for us to get the signals across between the systems for a pretty long time. But again, those licensing fees, you know, we're spending dollars on something that we don't need to. And the last point is just that, you know, the points about phased updates or future proofing, we deployed one of those proprietary DSP systems at one of the big theme parks near us in LA, and their proprietary system didn't actually have CobraNet. And so what that meant for us was that we were really dead in the water in terms of tiering the rollout against their capital expenses budget. And in the end, they just got enough money to basically do it in chunks. But we were literally looking at having to go down to AES pair breakouts to get in and out of these systems to tier it. And it was fairly ludicrous. So we're big believers in sort of open platform architecture, because that gives us the best chance to tell our clients, if you can't afford to do this all at once, you can phase it, and you have some protection against this still being valid equipment that you can interface with intelligently 2, 5, or 10 years from now. So that's all I got. Thank you.